to talk about our unit circles some more. So we're going to start just in our notebooks and then we'll look at that big circle I gave you. So in the unit circle, we have said that's a circle with a center at 0, 0. And the unit part of it means your radius is 1. So in the unit circle, R is always 1. We're going to think back a bit to the x, y, and r definitions that we used in the first chapter when we were defining our trig functions. We said because your radius is 1, we know theta is equal to s over r. The radius is 1, that means in this case, the angle and your arc length are the same wherever you are. So if I'm looking at right here, this angle is the same as this arc length. When I'm talking about pi over 2, that angle is pi over 2, the distance on the outside of the circle that it's traveled is pi over 2. But where this is really useful is if we think about our trig functions. Before, we said that the definition of sine is y divided by r. But on the unit circle, since the radius is 1, sine is just equal to y. So if I took the actual point anywhere on the circle, the y value of that ordered pair is equal to sine. Definition of cosine is x over r. But on the unit circle, the radius is 1, so cosine is just equal to x. Tangent is still y divided by x. That doesn't change. Okay, my other functions are reciprocals. Cosecant is the reciprocal of sine, so that's just 1 over y. Secant, reciprocal of cosine, so 1 over x. Cotangent, reciprocal of tangent, so x over y. So we are going to use this to add points on our circle. And then we will finally have the full unit circle. So this is a nice big copy that I've given you. We'll probably at some point start filling out, taking a few little quizzes where I just give you the small one and ask you to put everything on it. But this is your nice big one. If you want multiple colors, you can do that. We're going to start with all of our degrees, like we've done previously. So remember, this is 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. If we jump down here, this is 180. So 180 minus 30 is 150, 180 minus 45, 135. 180 minus 60 is 120. And the third quadrant, you add your reference angles, so 180 plus 30 is 210, plus 45 is 225, plus 60 is 240, and is 270. 0 degrees, we said, is the same as 360, so you can label it as either. Hi, how are you?
How about your calculators?
Yes. Are you bringing it back at the end of the hour? Yeah, no problem. You're welcome. So here we just do 360 minus each of these. So 360 minus 30. 330. 360 minus 45. 315. 360 minus 60 is 300. So, do you feel like you could put those on there? The next thing that we're going to add is the radians, which again, we've seen before. So, I'm going to switch colors. So my 0 degrees, you could call it 0 radians, or 360 is the same as 2 pi, so you could label it as either. You don't have to have both. What's 30? And the denominator just gets smaller as you go up. So 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. If I jump down here, 180 degrees is the same as pi. We know our denominators match the reference angle. What's the pattern in the second quadrant? So 5 pi over 6, 3 pi over 4, 2 pi over 3. So in the third, my denominators match my reference angle. 6, 4, 3. What's the pattern for the numerator in the third quadrant? So 7 pi over 6, 5 pi over 4, 4 pi over 3, 270 is 3 pi over 2. And in the fourth quadrant, same denominators. As you head out from the x-axis, what's the pattern for the numerator? So 12 minus 1 is 11 pi over 6, 7 pi over 4, 5 pi over 3. So that's the part we've done before. Now we are going to add ordered pairs. And these ordered pairs represent the actual points on the circle. So some of them we should know. If this is 0, 0, and I've told you the radius is 1, what's this ordered pair? So 0, 0, so if I go out 1, this is 1, 0. What would this point be? This is, What would this point be? Negative 1, 0. And right here would be 0, negative 1. The other points, we may not know them just from, it's not easy like the ones are, but from our previous slide, we know that on this circle, x is cosine and y is sine. So you might make yourself a note at the top. These ordered pairs, the x is the cosine, the y is the sine. If you think about it, 0 degrees, when we do our hand trick for 0, x is cosine. The cosine of 0 is radical 4 over 2, so 1. Sine is radical 0 over 2, which is 0. If I do 30 degrees, we have to do cosine first. So the value of cosine is radical 3 over 2. Sine, radical 1 over 2, so 1/2. At 45, if I'm doing my hand trick, cosine is radical 2 over 2. Sine is radical 2 over 2. At 60, cosine is 1/2. Sine is radical 3 over 2. Okay, and we can see our x's, as you're going up the circle, they're getting closer to 0. So it starts at 1, radical 3 over 2, radical 2 over 2, 1/2, 0. My y's are getting bigger because I'm going up. Now in the other quadrants, it's the same ordered pairs. So when I'm looking at a reference angle of 30 degrees, these are all very similar. When the reference angle is 30, it's always pi over 6. My points, these ordered pairs are all going to be the same for 30 degrees. So we have 3 over 2, 1/2. The only difference is we have to think about if you're plotting points in the second quadrant, x would be negative, which we've said before, cosine is negative in the second quadrant. In the third quadrant, what's true about both x and y? They are both negatives. And in the fourth quadrant, x is positive, but y is negative. This isn't different than what we've done before, it's just putting it in another place. You know, we have found the sine of 330 degrees in the past. And a couple days ago, you were doing sine of 11 pi over 6. Now if I say sine of 11 pi over 6, you could look at this circle and say, oh, that's the y value here. It's negative 1/2. All right, so my 45s. All of those angles are the same. The only difference is when things are positive or negative. So my point for 45 is radical 2 over 2, radical 2 over 2. In the second quadrant, the x is negative. In the third quadrant, both of them are negative. The fourth quadrant, x is positive, y is negative. At 60. Everything with a reference angle of 60. All those denominators are 3. My points are the same. The only thing that changes is the sum. So in second quadrant, the x is negative. Third quadrant, they're both negative. Fourth quadrant, x is positive and y is negative. Do we have questions? So this is the full unit circle with everything. Degrees, radians, and order pairs. I will not require you to fill out a unit circle on a test or anything. I will probably at some point do a quiz over one just to make sure you can fill it out. And then pretty much every test from here on out, I will have blank ones that you are welcome to fill out if it helps you on the test, but it wouldn't be a required part of it. So it's really not teaching us anything we don't already know. It's just putting it all in one place. So all we're going to do now is just practice evaluating some of these trig functions, so the problems that we've seen in the past, but using this circle to help us, or check our answers at least. So if I asked you to find these were the numbers that we were struggling with a little bit before. Okay, 3 pi over 2. That's at 270 degrees, right? So it's not really in a quadrant. And so every time we had one of those that was on the axis, not really in a quadrant, people kind of struggled a little bit. We talked about going back to the x, y, and r definition and using those points. We also can now look at this circle and say, okay, at 3 pi over 2, sine is x or y? Y. So at 3 pi over 2, my y is negative 1. So sine of 3 pi over 2 is negative 1. cosine. Cosine is the x, so at 3 pi over 2, the x is 0. Tangent. You can think sine divided by cosine or y divided by x. When you do that, what do we get? So we can use that circle to evaluate. In general, I still want you to do quadrants and reference angles, but you can use that circle to double check yourself, because you're not always going to have a filled out circle in front of you, so you don't want to use that as the only means of evaluating these. If I said 7 pi over 4, what quadrant is 7 pi over 4 in? 4. Reference angle, pi over 4 is what angle? So if I say cosine, we know in quadrant 4, all students take calculus, cosine is positive. Cosine of 45 degrees is radical 2 over 2. If I said sine of 7 pi over 4. Quadrant 4, sine is negative, sine of 45 is radical 2 over 2. Look at your unit circle that we filled out. If you find 7 pi over 4, cosine is the x, radical 2 over 2. Sine was the y, negative radical 2 over 2. So the same thing that we just figured out. Let's look at these. If I told you to find tangent of negative 5 pi over 3, what would you have to do? Okay. 2 is like 6 over 3, so negative 5 over 3 plus 6 over 3 is 1 over 3. So tangent of pi over 3, that's like 60 degrees. So tangent of 60 is good. If you check on your circle at pi over 3, tangent is y over x. So if you simplify radical 3 over 2 divided by 1/2, you get radical 3. Cosine of 2 pi over 3. What quadrant is 2 pi over 3? Reference angle is pi over 3 or 60 degrees. In quadrant 2, we know cosine is negative. Using your hand trick, cosine of 60, square root of the bottom over 2, so 1/2. If you look on your circle at 2 pi over 3, cosine is the x, we had negative 1/2. So use that to check yourself. Any questions about how those are related? I want to practice using our calculators again. So if it's not one of our angles that we are used to, so not something from our hand trick in our unit circle, we do still have that calculator option. But what do you notice on these? When I say 1.85, what does that not have on it? It doesn't have a degree symbol. So that means I am in radian modes. So you need to flip your mode into radian. So then we have cosine 1.85. If you are in radian mode, you should get negative 0.2756. Okay, cotangent. Remember, if you want to get cotangent, you have to type it in as 1 divided by tangent. So we get 0.2552. And how do we type in secant? So now we have both degrees and radians. We will flip back and forth, so you just need to watch that mode on your calculator. I ask you to find S in the interval 0 to pi over 2 if cosine of S is equal to 0.9685. Right, I don't know when cosine is equal to this. The 0 to pi over 2 just tells me I'm in quadrant 1. We have talked a little bit about inverses at this point, not a lot, that will come later. So pretty much at this point, if I'm asking you to do one on your calculator, I'm going to put it in quadrant 1. We'll worry about the other quadrants later on. But if I want to find S, the only way to move the trig function to the other side is to make it cosine inverse. Remember, if you want that on your calculator, you have to do second cosine 0.9685. In your calculator, it's not going to spit back something with a pi in it. It's going to give you a decimal, but that is the angle. And because I'm in radian mode, that's radians. It doesn't get a degree symbol. If I had flipped into degrees, then I would get a degree. But also, since pi over 2 is radians, that tells me my answer should be in radians. So when you're looking for an angle, that's when you do the inverse on the calculator. Final example. Find S in the interval pi to 3 pi over 2. Now, I just said I would do quadrant 1 if we were using the calculator, so we're not using the calculator for this one. What quadrant is between pi and 3 pi over 2? Think on our circle. Here's pi, here's 3 pi over 2. So that's quadrant 3. Okay, tangent is equal to 1. Referencing. When is tangent equal to 1? Think about your hand trick. Tangent of 0 is 0. Tangent of 30 is radical 1 over radical 3. Tangent of 45, radical 2 over radical 2, which is 1. So we're talking about 45 degrees, but what is that in radians? And and I want radians because pi and 3 pi over 2 were radians. So now my final answer, what's pi over 4 in quadrant 3? So you could look at your circle if you needed to, or we could remind ourselves in quadrant 3, the top is always 1 higher than the bottom. So it is 5 pi over 4. Any questions about these? So here is your assignment. 2 through 34 even, 52 through 68 every other even, and 70. Tomorrow we are going to review. I probably won't collect this until the end of class tomorrow, so if you need a little more time, you can work on it a little bit. I am also going to give a review handout tomorrow as well, so it'll kind of be a little bit of class review and then some extra practice for you guys. Book problems due at the end of class, and then quiz on Friday.